Hi, my name is Pat Meere. I'm head of geology here in UCC, and I'm going to just chat to you today about the options in the area of geosciences. So, I suppose the first question I'm going to ask you, are you interested in science and the environment? And have you thought about what subject you'd like to study if you are interested in science and the environment? And that's a very, very important question. In the case of CK404, which is Biological, Earth and Environmental Sciences, we have students enter the School of Biological, Earth and Environmental Sciences in the first year, and there's a common first year. You have a choice then after that first year, at the end of year one, of 9 degree outlets. Now, I'm not going to focus on all of these, obviously. The degrees that I'm going to talk to you about in this talk relate to the geosciences. So we're talking about geology, earth science, geography, and international field geoscience. There are basically the makeup of the first year, which is a common first year to all degree outlets, is quite varied. And you can see them here. It's a total of 60 credits. You do 2 geology modules, which is 10 credits. You do an environmental science module, a physical geography module, 3 biology modules, 2 maths modules, chemistry, 2 chemistry modules, and 1 physics module. And basically, the idea here is to give you a good general background in science before you make your degree choice in year 2. It also gives you a flavor of the different degree options that you can take, which is really, really important. So when you do make a choice at the end of first year, it's an informed choice. Geosciences, and when I talk about geosciences here in UCC, I'm talking about currently there are 3 degrees that come under that umbrella: BSc Geology, BSc International Field Geoscience, and BSc Earth Science. All 3 degrees are delivered by UCC staff in geology and geography. In the case of the BSc Earth Science, it's a 50-50 mix with geology and physical geography. Okay. The BSc IFG, which is International Field Geoscience, is essentially a geology degree, so it's a standard geology degree. However, you spend the 3rd year at the University of Montana and then come back to UCC to finish off your degree in year 4. It's important to say at this juncture that it's looking very likely that all 3 of these degrees will be replaced by a single degree offering, and we're going to call it the BSc Geoscience next year. That degree, that single degree, makes for us, it's making life a little bit easier, because quite often, people get confused with these different degree titles. So we'll have just one degree title, BSc Geoscience, but there will be different flavors of that degree, and basically that will allow you then to take your geoscience studies any direction you wish to take. So what is geoscience? I suppose at the most basic level, it's the study of the Earth and other planets, for that matter. It's not just the Earth. Its formation, how did this planet or planets form, the structure of the planet, the internal structure of the planet, its composition from core to surface to atmosphere, what makes up this planet, its history. Geoscience puts a big emphasis on Earth history and planetary history. It's a very applied topic, so it deals with looking at resources, physical resources that come directly from the planet. There are some topics that are particularly unique to the geosciences. Time is one of them. We look at deep time, from the birth of the planet 4 and 5.5 billion years ago to the present day. That gives us a unique perspective on what's happening on our planet today, and more importantly, what's going to happen to our planet in the future. And that's particularly relevant in these current days of climate change, etc. It gives us insight into the origin and evolution of plants and animals, and it also gives us an insight then into things like global catastrophes, volcanic eruptions, geohazards, climate fluctuations, etc. So looking at that long history of the planet gives us a unique insight into the planet now and in the future. Space, and what I mean here by space, that when you study geoscience across all the subdisciplines of geoscience, you get to think about the many scales of space. And I have 2 lovely images here. This is, on the left-hand side, a gorgeous, this is from Yellowstone National Park in the United States. It's one of these hydrothermal or geothermal, I should say, pools in the national park there. Just to give you an idea, that's about a couple of 100 meters across. You can see on the top left-hand side here a road for scale, and there's a scale bar. On the right-hand side, this is a piece of rock, a thin section. So this is a slice through a metamorphic rock. The scale here is 1 millimeter, and so we study in geoscience. We study from the microscopic to the megascopic in scale, and we need to be able to move between those scales comfortably, and that's something you get very good at when you study geoscience. Observation, and what do I mean by that? Well, geoscience is for those of you who are visual and like to visualize things and are good at visualizing things. Observations are really, really important in the geosciences. I would say they're the backbone of looking at the nature in the field, looking at landscapes, large landscapes that are quite static, but also looking at active processes like, for instance, landslides or a volcanic eruption. The two examples here. Coming back to the idea of scale, satellites have opened up, a whole new world of possibilities when it comes to observation and the scale of observation, and that is something again you will study quite a bit in the geosciences. Climate change, in terms of understanding what's going on in climate change, I would say geoscientists are absolutely central, front and center to understanding climate change and what's happening to the Earth in the future. We can go back, as I said earlier, billions of years. We can look how climate has varied and has behaved and why it has done that in that time span, which will help us to understand then the longer term impacts of climate change when we look to the future. And that increasingly is becoming more and more important, as I'm sure you're aware. Fieldwork. This is a nod inclusion here, but it really is a hugely important part of studying geoscience. From year 1 to year 4, if you decide to do a geoscience degree in UCC, you'll be doing fieldwork. And it's we find it's one of the most effective ways of learning about this planet of ours. Hugely effective way. We run field courses in Ireland, places like Antrim, Kerry, Waterford, Wexford, Clare. In third year, we take students to the Scottish Highlands and the Isle of Mull off the west coast of Scotland. We also take students to the Dorset coast, which is a spectacular coastline from a geoscience point of view. And in fourth year, we do a capstone field course in central Greece and look at active tectonics, earthquakes, and recent structures associated with earthquake activity. The point I want to make here is that you learn a huge amount, and students year in, year out tell us that the field trips are one of the best places to actually see in 3D the structures and the features that they talk about in lectures and get a real good understanding of those. Also, it's great fun. It's a great way to get to know people, to get to know your lecturers and the people running the courses. So I can't emphasize the importance of fieldwork enough if you're thinking about a geoscience career in UCC. Here are some examples. I'll quickly show you some of the destinations. The first years we take to the Giant's Causeway and to the North Antrim coast, which is a geological World Heritage Site now. Second year, we go to Dingle, the Dingle Peninsula, and spend a week doing various field studies on the peninsula. Year 3, I already mentioned. This is a gang from about 2 years back, I think, maybe 3 years back at this stage, on the west coast of Scotland on the Isle of Mull, doing some fieldwork in what is quite good weather, unusually for that part of the world. And finally, what you can always guarantee good weather in this place, this is central Greece, and this is some of our fourth year students looking at a delta system in central Greece, and taking some measurements from the sedimentary sequence that we see here. I think just to step back a little bit, a geoscience degree will I think will make you highly employable, and not just necessarily in the geosciences, which is important. So you're getting a good scientific training in a STEM subject area. That's important to say. But you also get a wide range of what we call transferable skills. You'll get good at fieldwork, independent thinking, because fieldwork requires you to think independently. Critical analysis, laboratory techniques. We do quite a bit of laboratory work. Software is increasingly important, and data analysis using software. Scientific writing, how to write a report, scientific report. GIS, Geographical Information Systems. There's a whole bunch of skills you'll pick up as part of the geoscience education. You get an opportunity for work placement in year 3, and all of our graduates in recent years have taken this opportunity. And it's a fantastic way to get a flavour of the type of work you might go on to do when you graduate. The employability in terms of the areas that we can look at, and this is just one slide, and I have to say this doesn't cover it because this is kind of focused more on geology, but you know, geoscience in the broader sensing has even more to offer. But just look at the range of topics and areas you could end up working in. You know, the left-hand side here we've got geochemistry, the right-hand side geophysics, the hydrogeology, looking at the water resources, environmental geology and engineering geology and engineering geosciences, up to natural resources, looking at mineralogy and volcanology. The career opportunities in the kind of sub-disciplines of the geosciences are enormous. There's a global shortage of geology and geoscience graduates. Check out Earthworks. There's the webpage there to give you an idea of the type of jobs that are available. UCC graduates are highly sought after nationally and internationally. We have a very good international reputation for our graduates. A lot of the careers these days are in environmental geology, hydrogeology, engineering geology. There is a big domestic demand, when I say domestic in Ireland, for these graduates. And we have, we continue, graduates will also have an opportunity to go on and do a master's or a PhD level in these areas. The Irish government has also significantly funded geosciences in recent years through the ICRAG Research Centre. So there is a national awareness that we need good geoscience graduates. And some of the obvious reasons for this is that, I mean, some of the critical metals that are required for things like smartphones, computer chips, for green technologies, car batteries, solar panels, etc., come from the need to locate the critical elements and metals that are needed for those materials. Hydrogeology, the search for clean and reliable water, is an increasingly important national and international issue, and there is increasing demand for these type of geoscientists. Environmental geoscience is a very broad area, and again, this is just giving you a flavor of the type of employment opportunities that you might follow. Waste management and disposal, contaminated land, restoring and industrial sites, and reclamation are all important aspects of environmental geoscience. Engineering geoscience is all about the application of geoscience to the infrastructure development, roads, tunnels, slope stability, etc. We have here in UCC a one-year taught Masters in Applied Environmental Geoscience, and that puts a strong emphasis on career skills and internships with employers. So you've got to, if this is an area that you would see yourself moving into, you have a great opportunity through this MSc program to do just that. I'm going to finish very briefly with two graduate profiles. This is Emily Archer. She did a geoscience degree. She did a geology degree in 2017. She then went on to do the masters that I just spoke about, the Applied Environmental Geoscience Masters in 2018. And she's currently a graduate geotechnical engineer with Fieldwork here in Cork. She's done a really good YouTube video, and I've just put the link here, and you can follow that. It's done in a kind of a carpool karaoke type style, but it gives a real good insight into what a graduate, an example of a recent graduate and what they can do with their career. On the other end of the spectrum in terms of the career stage, this is Mohan Mahal. Mahal is broadly the same age as myself. He graduated in 1993 with a PhD in paleontology, believe it or not. But then he went on, he joined the EPA, and he worked his way up through the ranks as a program manager in the Office of Radiological Protection for quite a few years. And then recently, I think back in 2016, he was appointed director with the Environmental Protection Agency. So has made a very, very successful career in Ireland with a geoscience degree. I'm going to finish up there because I accept I've packed a lot of information into these few slides, and I don't want to overdo it. If you've got any questions, and I appreciate we're working remotely here and online, but my name is Pat Meere again. I'm the head of geology. I'm more than happy to chat to you about your degree options and choices coming into UCC, so don't hesitate to email me and we can have a chat. Another good person to speak to is Dr. Ed Jarvis, and he's our first year coordinator. And he's a guy who's very experienced in dealing with student inquiries about career options. So listen, I hope you enjoy the rest of the day, the open day. And as I say, don't hesitate to come back to us if you've got any queries on what I've just spoken about. Take care.